Hello friends, welcome to Unacademy and welcome to the today's session. In this session, we are going to discuss about another fundamental of our basic of computer network. I'm going to integrate this transmission technology and communication mode with the help of our upper layer protocols like stop and wait, sliding window, and others. Before entering into the details of transmission technology and communication mode, we will say our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. So, to enter into Unacademy, you all need to do that, take an admission either for 12 months or 24 months, then you can able to enjoy all the things which are there in Academy portal such that daily live classes and live quizzes and doubts clearing sessions and one is to one faculty interaction and many other features are there. So you're going to see that real class environment, virtual mode that is only possible with an academy. About myself, Srinivasrao, I is having more than 15 years of experience in the CSE stream. I also had industry experience as an analyst and database admin. Throughout my journey of GATE, I taught in many premium academies, including MEDIZI, GATE Forum, GATE Academy, with a high success. So, throughout my journey of GATE, I taught in many premium academies with a high success rate, and many of my students have completed their post graduation in a topmost premium institution just by cracking a GATE examination, and they are also successful in achieving the campus placement too. They are all working as a topmost software professionals in topmost MNC company. So you also can be like that just by obtaining admission. You just give your valuable admission and an academy is take care of you everything. As I am also part of an academy. There are two types of subscriptions are there, 12 months and 24 months. So third and second year students can able to obtain 24 months subscription. There you are going to get many kind of recapitulation lectures and many. If you would like to interact with any faculty member who are in an academy, just fill this form. Then they are going to allocate one of the required or desired faculty member so that you can able to interact with them for any further guidance. Let's Crack Gate CSC is our YouTube channel. Subscribe our YouTube channel. Use my referral code to get the maximized discount. Hit the bell icon for the latest updates and notifications. So what is a transmission technology? So many of our people knows that in real-time communication, as this is one of your basic requirement to do any kind of communication, how you're going to provide the communication with the other party. That is our today's agenda. Number one, how you are going to communicate with other party. Number two, how your data is going to flow between two particular parties. That's why it is called as a transmission technology and a communication mode. So why this is related with our advanced computing networks? Now I'm going to give you some of the real-time examples. So therefore, you will understand why we are learning a transmission technology and how that is communication mode in this lecture. So if you look at what is a transmission technology, it is also called as network hardware, also called as communication casting. Communication casting. Whether you are going to do unicast or whether you are going to do broadcast or we would like to use groupcast communication, which is nothing but a multicast. And number four, ecast. Number five, podcast. So, we people are very much about these three, and I'm going to discuss in detail so that how it is completely relevant to our particular upper layer protein. So, when you are talking about the unicasting, when you are talking about the unicasting, so unicast, it is also called as one-to-one communication. So naturally, often we regularly observe one is to one communication time. Why? Because there is a node 1 who is trying to communicate with a node 2 with the help of some medium. So since there are any other intermediate nodes are there between N1 and N2, I can say that N1 is try to establish or try to communicate one is to one. So that's why it is also called as what? Point to point, also called as what? End to end. So what is the advantage of this? The advantage of this is nothing but you see that. So you see in this what is going to happen? The channel or a frequency, whatever it may be, channel is shared only between two nodes. So therefore what is going to happen? See that one end a sender is available and other end receiver is available. That's why you can able to say that only 2 points. So sender, I can able to say that 1 point, and receiver, I can able to say that another point, and both are trying to establish communication with the help of one is to one. So here, the channel is going to be shared. That means what? It is going to be shared only between two nodes, not by the several nodes. So because of this point, you can understand that what is the advantage. Because of this point, the advantage is that you're having the concept of the privacy because no other guy between sender and receiver, and you're also having what security, your data is exactly is going to be delivered to other party. And what is another advantage is that, so apart from privacy and the security, you can also say that ordering ordering of data is there. But what is the disadvantage? If you say the disadvantage is very simple, that's nothing but I can able to project that it is inexpensive. Why it is expansive? You see that I'm saying that there is a node 1 and there is a node 2 and there is a node. They are involving in order to transmit their data with the help of recast mode or point to point mode. Therefore, between this, nobody is supposed to be available in order to share your channel, and this channel is must not be shared with by others. And so there is a requirement of what? There is a 1 is to 1 between N1 and N2, and this channel cannot be accessed by other particular nodes. So therefore, between N1 and N3, one more 1 is to 1 is. So for every two nodes, I'm going to take a, one of the medium cable. Here medium or a channel is being shared only between two. Now you see that in order to have the communication between these two, again there is a requirement of what is to one. Therefore, friends, you observe carefully how many channels you all require. That's why we can call it as it is expansive. How many channels we are projecting here, which is n into n minus channel. Because between every two nodes is supposed to establish the channel, and the channel must not be accessed by others because it is a 1 is to 1 communication. As here n is nothing but number of nodes, so 3 nodes into 2 by 2, so there is a requirement of what exactly channels. As far as that, this you can say that line 1, this you can say that line 2, and this you can able to say that line. That's why it is an expansive concept. But advantage is superb. Why advantage is superb? Whatever data is transmitting by N1 and N2, whatever data is transmitting by N1 and N2. So that is only in between, or the conversation is only in between those two parties only. So other guy, if at all they try to access the channel using N3, then we can say that it is not possible. Because of that, we are using the concept of point to point, also called as unique casting. So here, for the real-time example of this point to point, the real-time example of this point to point, we are all saying that normal general example, that is a telephone, two persons how they are talking, and the other one we are also saying that a mobile communication is also fine. But another example I want to give you in related to your now I'm saying that there is a sender 1 and there is a receiver 1 and there is a receiver 2. For example, if this S1 would like to transmit the data to R1 and not to the R2, this is what exactly the meaning of what point to point communication. Say sender is a S1 here and the receiver address also I'm going to write as a destination address. I'm calling them as a what? R1 here. Therefore, this packet, whatever you are saying, the packet name is a 1, will exactly transmit it to this particular R1, not to the R. So here we are using a concept called as what? One is to one communication logically. Logically in the sense what? So I'm sending the data from S1 to R1 by using this kind of a channel. I'm specifying address like S1 and R1. So this is what is the real-time example of that. Apart from your telephonic network and mobile network, I can able to say that point-to-point networks are much more needed. So there are many kinds of applications are there, like satellite channels and many others are the examples of this. Now, if I am saying the example is like this, there is a sender and there is a X and there is a Y and there is a Z, and I am delivering the packet. The packet name is a packet 1 and I'm writing the source address that I want to say source is X and I want to say that this S is supposed to release the data packets to all the guys at a time. So would you like to transmit it like this? Then it is not a 1:1. So if you are having a different channels, then no problem. If I am having a 3 channels, so I say that it's a line 1, okay, you can. It's a line 2, okay, you can. If it's a line 3, yes, it is also you can. So in all the three, I can able to say that the one-to-one transmission. But you say that one packet is being transmitted to multiple persons, then it is not what I mean to say logically 1:1 communication. But as far as a transmission technology concern, it is a unicasting. Why? Because I have got the several lines, individual lines, but the same packet is being traversing to multiple person. I can able to call it as a what? One-to-many communication. Now let us see the second variety, that is called broadcasting. So now we are learning about the physical network hardware, physical transmission I am saying, not the logical transmission. Physical transmission is nothing but whether your data cable is shared or not. If your data cable is not shared, it is a one-to-one. If data cable is shared, it is a what? One-to-many communication physically. Logically, how to do, we will see in a later on classes. So what is a broadcast here? The broadcast is nothing but what? Your channel or a medium. Medium is just shared among all the nodes. Medium is shared among all the nodes. This is the concept. Therefore, what is going to happen? You see that all nodes can able to place data, can able to place data onto medium. There are some problems if you are looking at this structure. So that means what any node can able to send data anytime. That's the meaning of broadcasting. So here what is going to happen as far as the definition concerned. So there is a medium. This is your media which is shared between many nodes, which is shared between many nodes. I can call it these node numbers I'm going to give you. So this is called node 1, and this is called node 2, and node 3, and node. So there are 4 nodes who are trying to access the shared channel. It's not a dedicated channel. If I'm saying that dedicated channel, it is the concept of what? Point to point. So point to point, when you are talking, there is a requirement of what? Dedicated channels. So when you are talking a dedicated channel, then this is a 1:1 only. So in that the channel is not going to be shared by others except both the parties. So in internet you can talk. Laser line is also one of the another example of this. So unicast communication, you can say that many of the examples. So apart from telephone and mobile, you can say that laser line. So laser line in the sense internet laser line, famously known as ILL. So it is a 1:1. From exchange, it is being connected one end, and other exchange is going to come to your particular office or your particular home. So there will not be any other person except the exchange point and yours point. So that's called ILL. So you're going to get a what? Dedicated bandwidth here, which is unshared. Now look at the concept here. What is that? Your channel is under shared mode, not the dedicated mode. Therefore, what happened? Whatever the nodes would like to communicate or connect to that channel, they can able to connect. So what is the problem here and what is the advantage here? So I can say that it is it is 1:many communication. Why it is 1:many communication? We observe. That's how, like this. So whenever node 1 would like to transmit data, he will place the data onto this media only. When he places the data onto the media, then what is going to happen? Last session we learned to place your data onto the media is going to take a transmission time. And this data from start of the point to end of the point, it is going to traverse like this. So when it is a traversing from start of the point to end of the point, this is your start of the media, this is the end of your shared media. And over the nodes get connected at that time. So there are 3 nodes, 4 nodes are get connected including me. So one is a pushed the data, it comes to this party if he is alive, and this comes to this party if he is alive, and this drops the data to this particular party if he is alive. Therefore what is happening? As the nodes are sharing your channel, then it is going to see that everybody is going to get the message whatever is being pushed by other party. That's why we can say that when one particular sender is transmitting the data and the data is going to be passed to all the nodes who were active at that particular time, including us. Broadcasting means what? Including us. If you are sending a message in WhatsApp group, as you're also sender, you could also able to see that. Please understand, broadcasting is nothing but you're going to get a message including to along with the other particular group members. So what is the advantage here? So you say in this broadcasting advantages, as I am using only single channel, please understand. The advantage here is that as I am using a single shared channel. So when you are talking about the single shared channel, then I can say that it is inexpensive. Why inexpensive? Because of one channel and many nodes I could able to connect. But as far as unicasting concern, you might be understood that n into n minus 1 by 2 channels are required. That's why it is very expensive. Apart from channels, there are some Ethernet ports also required. So Ethernet ports in the sense, please understand friends, in the unicasting concern, I want to connect it to 2 nodes. So you want to connect it to 2 nodes in the sense, so node 1 and node 2 and node 3. So here what is going to happen? There is a need of a one port and here there is a need of Ethernet port. To this Ethernet port only we can able to inject your twisted pair cable. These ports are being connected with RJ45. This is also connected with RJ45. And here also there is a need of one more port, and here also there is a need of one more port, and to this port I can able to integrate with this port, and this is also I am using RJ45 cable or jack. So between this and this you want to have the communication. Again there is a requirement of port Ethernet port where you can able to use RJ45 jack. So it is so much expansive as far as a point to point concern because of issue only. So we want to see that inexpensive concept, but inexpensive concept when you are talking, you need to see a concept called one to many communication, also called as a broadcast. So simply broadcasting is nothing but, my dear friends, the sharing of the channel. It's not the one to many exactly. Sharing of the channel automatically will tell you that one to many communication, because whenever one party is trying to put the data onto the media, and that particular data is going to be carried forward from to other particular place, hence everybody is going to get the chance to. This is the first number one. And what is the disadvantage? If you are looking the disadvantage here, very simply I can say the disadvantage that no security as well as no privacy. Because when I'm sending the data, then if other guy able to see or able to listen or able to watch what is happening between two parties, then it's not a concept of what you are sending the data in a protected mode. So that's why you can say that as multiple members able to see or watch your data, hence we could able to say that there is no security and no privacy. This is the point. And now in a broadcasting, the real-time examples, if you are talking where this broadcasting is used, for example, telling you broadcasting like TV broadcasting, many of the people will say that TV broadcasting is one of the examples. Yes, I can agree. As well as your FM radios is also another example. So these are all real-time examples. Apart from that, toward respective to computer networks, we will see like this. There are few users. Already we have seen this example, and there is a node 1, and there is a node 2, and there is a node 3 who are connected, who are connected to one particular hub or a switch, who are connected one particular hub or a switch. Now I got connected to this, and I got connected to this, and I got connected to this. So we are all got connected with the help of a 1:1. So dedicated mediums are there. I too agree, as I am doing unicasting here. But unicasting, I am doing a what? A 1:many transmission. How you can able to do 1:many transmission? Please understand. So when we are talking a broadcasting, don't say that it is a 1:many communication. When you are saying the concept of a broadcasting, it says that your channel is supposed to be shared by multiple person. If channel is not shared, it is a 1:1 communication, no doubt. If your channel is shared, it is going to be 1:many communication. But here we are seeing a different scenario. What is the scenario? I'm not going to share the channel. I'm using a 1:1 mode only. But I want to do 1:many transmission in the examples of unicasting. So here what I'm going to do, in such cases, we are going to use the concept of what? Broadcasting address. So that means as far as that example concerned, I'm doing a what? Broadcasting. But I'm not going to share the channel. Please understand. I'm not going to share the channel. Simply I'm saying that broadcasting. So friends, here what is going to happen? Whenever this node place the data onto your switch or hub, whatever it may be, so I'm going to present a few important information that who is the sender, and then the destination. I'm saying that there are other nodes also get connected, and other nodes also get connected. They are all get connected dedicatedly. There is no media sharing here. Everybody is having a 1:1 to your switch to node 2, switch to node 3, switch to node 1. They are all using a 1:1 channels only. Now, how are you going to do one to many communication here? A very beautiful question this is. Now, Source address I am writing as N1. If I am writing my destination address is N2, this is going to be a purely 1:1 communication because your packet will exactly goes to N2 only. If I am saying the source address, if I am saying that N1, and the destination address, if I am saying that N2, it is also 1:1 communication, no doubt, because the packet is just will arrive to N2, not to anybody else. That too, I am using the concept of what? A switch. Now, if I am talking another example that source address is N1 and destination address, if I am saying that network broadcast address. What is a network broadcast address? We will see from the tomorrow's session. So where I am going to start IP addressing. So destination address, if I am specifying in the packet, these addresses are available in the packet only. So therefore, what is going to happen? This packet, even though you are using a what 1:1 channels as your part of unicasting, but the data is going to be passed to how many guys because of this example? Please understand. Source address is the N1 and destination address I am saying that network broadcast address. Therefore, all this packet is going to be transmitted to all the nodes who are having the same network number or same network group. Therefore, friends, you see that here I am going to say that one to many logical communication, even though the cable is not going to be shared by using the concept of what network broadcast address. So we are using a network broadcast head address concept such that the data packet is going to be transmitted here to N2 as well as to N3. They are belongs to your network. What's the real-time example of this? The real-time example of this is nothing but Airtel to Airtel. If you are saying, for example, if your network is Airtel and Airtel is going to send a message to all the guys. So all Airtel members, Airtel is going to send some kind of promotion messages or some kind of, you see that common messages. So in that case, everybody is going to get the message at the same time. So this is the concept of what? One to many, as all your belongs to Airtel network. Please be seen that this message is not going to transmit it to Geo network people or BSNL network people as they are not belongs to Airtel network. That is the concept of what? Network broadcast address. When you are talking a network broadcast address, the single packet is going to be diverted to multiple persons even though they are not sharing of your media. Logically, this is going to be done such that all the people who are connected to the same network, who are belongs to same network, you're going to get what? Yeah, this is what is the meaning of a real-time example of your broadcasting logically. Physically, I also said, what is that? Physically, you want to do broadcasting like cable network. Now I'm going to tell you physical broadcasting. When you say physical broadcasting, so the previous example we have seen that I'm using a 1:1 channel. Even you are using a 1:1 channel, how we able to send the data to the many people? That's what the meaning of logical broadcasting. There are three varieties. One is a network broadcast address, and the other one is a subnet broadcast address, and the other one is a what? Directed broadcast address. There are different varieties of broadcast addresses are there, and the other one I can also say that limited broadcast address. So NBA, SBA, DBA, LBA, they are purely for what broadcasting the data to multiple persons, even though you are having a concept called 1:1 channels. But what is the meaning of physical broadcasting? Come to the point. So physical broadcasting is nothing but your physical medium is shared now. Physical medium is shared by all nodes. So when you say that physical medium is shared by all the nodes, then it is called as a physical broadcasting. Here what is going to happen? The real-time example I can say that your cable TV. Your cable TV is one of the best example. Either you are using a dish TV or you are using a normal cable TV, you can say that a single cable or a single spectrum is being shared by multiple number of parties. Therefore, whatever the cable provider is producing or broadcasting, then the same information is going to be passed to all the people. So he is the cable provider. He just to generate the data here. As soon as he generate the data, this data is flowing from the medium one particular point to other particular point. So whoever got connected to that particular media, then we are all going to get the same broadcasting, node 1 and node 3. Here I'm not using a dedicated channel, so I'm using a shared channel. As I am connected to the shared channel, I'm going to get the shared data, no doubt in that. So it is the concept of physical broadcasting. The logical broadcasting is different from your physical broadcasting. In logical broadcasting, I need not connect it to the shared medium, even though I belongs to what a dedicated channel. But some sender would like to send a broadcasting data to all. Yes, it is possible with the four things I said: NBA, SBA, LBA, as well as DBA. Now, this is one of the example called cable TV or radio broadcasting. As I also said, radio broadcasting. There also, if you are tuned to one particular frequency, then all are if at all are tuned to same particular frequency, as you're all accessing same frequency only, then what is going to happen? Whatever is the radio broadcaster broadcasted, that we are going to get at the same time. So there your frequency is shared by multiple number of people. What are the disadvantages in this? We have seen that what? No privacy and yes, no security, because data is transmitted to each and every person. And there is one more variety that is called multicasting. So what is the concept of a multicasting? So multicasting, when you are saying, it is a what? Group communication. So when you are saying that group communication, the few examples you can able to say that, I can say group talk, or you can say that group mails, or you can say that group messages. They're all comes under into multicasting. So here also, what is the principle here is that the principle is channel is shared among all the nodes except non-group members. So all the nodes, but data transmission is done only to the group members, not to the non-group members. Data transmission is done only between group members. Well, friends, what is the real-time example of this? So real-time example, I said, these are all the real-time example only. Apart from that, our computer network related real-time example, if you would like to ask me, what is the real-time example of your multicasting? That is token bus. That is called a token bus system. What is a token bus, friends? It is the standard of IEEE 802.4 token bus system, such that here also there is a what? A long channel is being shared by several nodes, no doubt. So it is a very one of the flavor of your broadcasting only. So there are different nodes are connected to this. Please understand, 5 nodes got connected to like that. But here we are trying to make or form a group here. What is that? Whatever data 1 and 2 and 3 are saying, the data is supposed to be communication or supposed to be handing over or transmitting via between these three nodes. Then they are going to create a what? Some kind of groups here. So I can call it that this is the group 1, and whatever data the 4 and 5 are exchanging, they are becoming a what? Another group. Therefore, my dear friends, here what happened? Even though the channel is physically shared among all the nodes, but data is not going to be passed to everyone. That's the concept of multicasting. It is also one of the simple example of one to many, such that whenever one particular person is release the data and data is going to all the parties, as they're also shared your channel, but it not goes to all the parties, only to the group person. So that WhatsApp grouping. And in Gmail, we are having a called group mails and group chat, group communication, group calls. They are all comes under into multicasting. So here what happened? When anyone would like to send the data, first the data is going to be placed onto the media. So then it started transmitting from one end of the point to other end of the point. But you see the data can be received by 2 and by 3 and not by 4 and not by 5, even though they got physically connected to your channel. In such case, this group one members are isolated from group 2 members even though they physically connect. So that's the concept of multicasting. So which we are really implementing in the IEEE 802.4 standard. That is nothing but what? Token. It is somewhat different. It is somewhat better than your broadcasting because we are able to send data to only group members only. Who is responsible to do? To the point. In real time, when you are talking, I said that there are three methodologies. One is not share your data, not share your cable. The other one, share your cable. And the other one is also share your cable. The first one, we are saying that it is a non-shared mode, also called as a dedicated channel. And the second one, you are talking that these two are under what? Shared channels. So which protocol is responsible in real-time data transmission and unicasting? This is very important. In unicasting, the internet protocol take care of this. Who is responsible to do the broadcasting here? And who is responsible to do the multicasting? This is a very, very important question. Who is going to do multicasting? So IP cannot able to do the multicasting here. So IP is a helpless. And immediately there is a protocol called IGMP. Then IGMP it's take care of doing what? Multitasking. Whenever you talk about the multicasting communication, then what is going to happen? Your IGMP, Internet Group Message Protocol, is going to be configured in IGMP routers. Now here, IGMP routers are responsible to do this kind of what? Multicast transmission, not by anybody else. So here IP is nowhere to do any kind of a broadcasting. Only IGMP protocol, Internet Group Message Protocol, is done in order to do your multicasting communication. Friends, understand? So that's why we are learning transmission technology, even though it is one of the funda concept. I'm saying that how this is to be integrated to your real-time computer network. Only IP protocol is involved in unicasting, but you want to do the multicasting concept. There is a requirement of specialized routers called multicast routers. They are called as IGMP routers. In that, you're supposed to configure IGMP protocol. Then whenever data comes to this IGMP routers, in that router we already configured the groups and the data is going to be transmitted to such kind of groups. This is what real time is happening in Airtel, Jio and BSNL network, that they already might have configured these IGMP routers such that whenever they broadcast, then data is going to come to everybody. What is the meaning of a broadcasting here? You know, our Prime Minister Sir is doing a Mann Ki Baat. So everybody is going to do what? Broadcasting that. So in that case, you can able to see a concept of what? Broadcasting. Even though we are all belongs to different kinds of a network, Airtel or Jio or BSNL, as we are all sharing a single spectrum from Government of India, that's why in that case we are calling it as what? Broadcasting. So please understand there is an internet protocol and there is a what? IGMP protocol is responsible to do this kind of multicasting. So we apart from that, we have other concept which is linked with this transmission technology, that is called communication mode. So communication mode also is very much required for us in real-time data transmission. First, let us see few of the points which are there as far as point-to-point communication. The point to point is called as a unicasting, as I said, and one is to one communication. The single communication channel is only shared between two nodes. That's why there is a requirement of what I said. Only one member is responsible to configure the channel. The remaining node can able to accept the data simply. So that's why we need only half of the channels when there are n number of. So that's why it is a concept called n is to n minus. And another point is that you can able to configure in wired as well as wireless, but there is a requirement of a dedicated path. Dedicated path means what? For example, I am the member, I got the telephone, and here is the tower. Please understand. From this telephone to this tower, you are supposed to have a dedicated channel. That's why it is called a one is to one concept. So this can be used in a half duplex and full duplex mode. We will learn in this session only. And what are the real-time examples of them? Star and mesh, as well as lease lines and give a microwave links. So why star and mesh are coming here? If you look at the star, this is one of our topology. Star is nothing but it is going to act as a central controller. So all the nodes are supposed to connect to our central controller only. So therefore, what is happening, friends? There are four nodes which are connected to your hub or a switch, whatever it may be. Now it is what is going to happen. Whatever one is trying to send, the data first comes to central controller. From there, it is going to redirect based on the destination address, whether you want to go to 2 or you want to go to 3 or you want to go to 4 or you want to do logical broadcasting. That is up to you based on your protocol which you are using. But here you understand carefully. If I am saying that this is a star, therefore a 1 to 1 channel, 1 to 1 channel, 1 to 1 channel, and 1 channel. So this is how it is going to happen. In the same way, it is also be done in mesh networks also. And we have physically sharing. It's not logically sharing, physically sharing. So that's why what is the meaning of that? Your medium is shared by many number of nodes. So data broadcast to all the users, which can be done using a SBA, DBA, NBA, and LBA, limited broadcast address, and real-time examples of what? Bus center. What is a bus centering? So you say that if you are understanding ring topology, tomorrow we are going to learn what are the different topologies, what are its pros and cons. That is another fundamental, last fundamental to us before going into next topic. So there are four nodes I have connected to in a circular fashion. Now you see that if I ask many members how many channels are there between these parties, so many many numbers says that 1 to 2 one channel, 2 to 3 another channel, 3 to 4 another channel, 4 to 1 another channel. But that's wrong. The answer is that only one channel. So only one channel that is being shared among several nodes. So you can also call it as what? It forms into circular fashion. And other one is nothing but a bus, as I already said that. So if this is the cable like this you are using, and many nodes can able to connect it to this. So whatever data transmission done by one here and there, and the data will come to and circulate each and every particular ring, and it comes back to the. And the next one is that multicasting. Here also data is the medium is going to be shared, no doubt, but data transmission is restricted. It is going to be transmitted to what? Only few members. Real-time example is nothing but multiplexed broadcast. So for example, so token bus is one of the example, Ethernet multicast addressing, and asynchronous transfer mode. This is another area example, and point to multipoint. Point to multipoint concept is nothing but you are taking a one node and there are multiple nodes are like this. So there are four nodes like this, but I want to say that the data transmission I want to restrict it to only these three particular nodes. Therefore what is going to happen? One to multi-point there, one to many. That's what the meaning of one to many is nothing but what? Point to multi-point. So from this particular point to I'm going to send my data to multi-point. And we have data communication mode. How are these are very useful in real-time data transmission? It is telling that how your data is flowing from one particular node to other particular. So immediately everybody got understood that there is a what simplex data transmission. Simplex data transmission is nothing but what single mode. It's not a dual mode. Dual mode, and many people are calling that it is a unidirectional. So where this is really implemented, our textbooks are giving example that the keyboard is one of the example to this simple. Yes, I do agree because you are giving input only. But apart from that, what is another real-time example? You please listen carefully. If I am taking error-free channels, if I am taking error-free channels, so here what is going to happen? Error-free channel is nothing but you never find any kind of error during data transmission. Therefore, node X is trying to transmit data to Y. Node X is trying to transmit data to Y continuously. Please understand. Node X is trying to transmit data to Y continuously. So here I can able to say that X is going to call it as a what? A sender, and Y is going to call it as a what? So here Y is not going to be respond any kind of data transmission. So data is only one-sided, not the double-sided you can call. So that's why keyboard is one of the example. Another example I can say that sender would like to send always data to the receiver. We are not expecting any kind of acknowledgement from him, and we are not expecting any kind of a data from him. So data is going to be passed in a single direction from X to. And if you are look at double mode operation, double mode operation is nothing but what? Duplex. You can also call it as dual mode. So what is a dual mode? It is a bidirectional. So this bidirectional is, we have two varieties. One is off, off sending, off receiving. The other one full, both can able to send as well as receive. So you all know why we are learning once again off duplex and full duplex as their funda. But I am trying to integrate to your computer network. Observe carefully. When I am saying off duplex devices, it is telling that we can send. That means what? Nodes can send or receive. Nodes can send or receive data. No problem. And the next point is that what? Both parties, both parties either can send or receive. This is what is the concept of half duplex. So here what is going to happen? Your link efficiency or line efficiency is exactly half of total efficiency. Why? We'll see now with a diagram. Please understand, friends, what the half duplex is saying. Why we got 1 by 2 efficiency always? Why it is called as half duplex? Why it is giving always 1 by 2 efficiency? Because please observe this diagram. There is a S and there is a R. So S started transmission. You say packet 0. So receiver cannot able to immediately send because bidirectional is not possible. Once after transmission is done by S, then S will say that I have got completed my transmission, therefore you can transmit. So after that, as this is S data, S packet 0, then after indication that, so sender will say one more in control information that I have got completed. So sender will say that control information that I have got completed my data. Then immediately the receiver could able to send the data other time. So he is sending receiver dot packet 02 to him. So therefore, after transmission of data, sender must not respond here. That means S must not respond because at a time is not possible to. Again, he will send a what a control information that I have got transmitted my data. So this is how you need to say what your data as well as you need to say what a control information to the other party that data transmission got completed. Otherwise, you are going to have a concept of a what conflicts. That's what the point. What is that? If both nodes if both nodes at a time transmit data, then there is a chance of what? There is a chance of collision. That's why off duplex will say that because to avoid the collisions, what off duplex is saying, better to give a control information so therefore other voice is not going to be interpreted or overlapped with your voice. That's why the real-time example of your half duplex is nothing but whenever you send data, other party wait and receive the data unless and until he must not start unless and until he receive what control information from other particular party. That's why until this process got completed, the medium becomes idle. So because the medium becomes idle, I can say that it is only 1 by 2 efficiency because the medium can be utilized only one party at a time. Out of two parties, only one party is always busy in sending, other party is only in busy of receiving. When others are sending and you are going to be under what receiving more, because of this point, what is that? There may be a chance of what? Where are we going to use this off duplex communication? Point number two. The real time applications of your half duplex communication is your bus. Bus is one of the real time example, and your token ring is another one of the type of example. And we have the concept of a token bus is another real time example. As it is fit for what half duplex communication, you cannot have the concept of what full duplex communication here. There may be a chance of what collisions. So that's why when I'm talking a bus, so indirectly you have to talk half duplex, ring half duplex, and token bus is also what half duplex communication. As there is a what medium is got under what sharing. Other real-time examples also there is that your one of data link layer protocol that is called stop and wait. So stop and wait protocol is the best fit for half duplex because in stop and wait we are going to see that the maximum of what I mean to say bandwidth, less utilization of bandwidth in stop and wait protocol. So stop and wait also, we see that we are going to use off duplex communication when you are having the concept of wider network and internet content. Okay, friends. So this is another example. So what is the control info? Naturally. So our textbooks are saying that the real-time example of this off duplex is nothing but walkie-talkie. Yes, I too agree that walkie-talkie is another. So why? What is the control info in walkie-talkie we are using such that your conversation got completed? You all see that over. So when other particular party got completed transmission and immediately he will say that over. When he say over, then the second party can able to start communication and after that he has to give that over. Unless and until over is given and unless and until it has come to you that control information you cannot able to start communication. So therefore, medium is going to be utilized only by one party at a time. Hence, it is going to give you always a 1 by 2 link efficiency. And the last one, when you are talking, that is a full duplex channel. So when you are talking a full duplex, it is also bidirectional, but very effective. In this, both nodes, both nodes can send and receive. There we have written or, but here you can receive data at a time. Okay, friends. So therefore, every node has to maintain two windows. Every node has to maintain two windows. One is for sending data, sender window. The other one receiving data is nothing but receiving window. Please understand. So both windows need to run parallelly, because one time we are sending the data, other time we are going to receive the data. So here both nodes are sending and receiving data, therefore efficiency is going to be very high. So your line efficiency is effectively used. Your line efficiency is effectively used. So what is the real-time application? The real-time application, when you are talking about the full duplex channel, that's nothing but your telephone. So your telephone network is bidirectional communication. Your mobile network is a bidirectional communication. Your computer network is also bidirectional communication. Whatnot, everything is under bidirectional communication. So what are the real-time protocols which are offering the full duplex? So that's what we want to say. Real-time protocols which are supporting full duplex communication. Point-to-point protocol is one, and the second protocol is sliding window. This is one of your data link layer protocol. Sliding window protocol is also supporting a full duplex communication, and the other one go back and is also using a full duplex, and the other one SR protocol is also using your full duplex channels. So these are the real-time examples who are effectively utilizes your channel, so that both the parties sending as well as receiving the data is possible. Let me give few examples here. So there is a node 1 and there is a node 2. So both are ready to send and receive data. He is sending and the other side is also sending. Please understand. And this side he is also sending the data, and the other side he is also able to send the data. Therefore, this blue dots is a N1 data and black dots is your N2 data. So you're supposed to maintain two windows to order your data, sender window as well as receiver side. The sending means what are the frames you send. Receiving means what are the frames you received, or what are the packets you received. So both end is supposed to maintain in this. So therefore, my dear friends, here what is going to happen? The other party is not going to wait till the conversation is got completed. So it able to send your data both the bidirectionally. Then I can able to say that your medium is not at all idle anywhere. Your medium is not at all idle anywhere. As much data you are having, you can able to transmit that much to other party. That's why your channel efficiency or link utilization or link efficiency is going to be always max. Up to 100% you can able to get when there are no congestions and no collision. This is what is the meaning of a full duplex. If you are looking at the half duplex, we already seen that data will be passed only one direction. After receiving the data other party, then you can start transmitting your data. So the protocols which are given to you, point to point, sliding window, go back, and SR protocol, they are maintaining both the windows so that you can able to order them. So here what happened? Sender send first packet. Here receiver received N1 data, N1 packet 0. Then he sends the data. So I am putting that in the my receiving window. So N2 data I have received. So this is how they are going to see that. So he sent what? He sent a packet number 0. So that packet is going to post in the receiver side. That means what, in receiving window. And this packet, whatever is sent by the N1, and that information is going to be written in other side receiving window. So this is how, friends, how you can able to say that if I am giving any diagram or if anybody asks you, so let me give an example like this. He sent and he sent, and the other side also we are going to see that two different packets are coming other side. Then in that case I can able to say that it is a full duplex communication. So only one side you are transmitting, and after that I am giving a control information. Then it is called as what? Half duplex in communication. Right now we are all using a what? Full duplex communication only. Why? Because we want to utilize the channel maximum up to 100%. So what are the points are there? So it is a single mode communication. Communication is a unidirectional. Only among the two nodes, only one node could able to send always, and other node is going to be always receive. Okay, friends. So for example, you say one always broadcasting the data to other party, then you can able to call other party is about receiver, and myself is always sender. So data transmission you can do in error-free channels, or keyboard is also one of the real-time example. And hop duplex is a dual mode transmission. So bidirectionally is possible, but only one at a time possible. So link efficiency, how much I said, 1 by 2. Real time example, walkie talkies and stop and wait and stop and wait ARQ are the two protocols. When you look at the full duplex communication, so both nodes can transmit and receive data simultaneously. So line efficiency is a maximum utilized. For the real-time example, SWP, go back and select to repeat protocol, and the transport layer is also using a what? Full duplex communication only. Well, friends, so these are the differences, how the transmission technology and communication modes are really we are using. Right now, we are using point-to-point transmission technology with the full duplex. The point-to-point can support half duplex, and point-to-point can also support the full duplex. This is the important point. So in point-to-point, I am able to say that it supports half duplex. In point-to-point, it also supports what? Full duplex. But when I am talking broadcasting, please understand, when I am talking a broadcasting, in broadcasting the medium is shared by many nodes, so it is called as a shared mode. When I am saying that it is under shared mode, then I cannot able to do what? Full duplex. Here full duplex is flop protocol, so you have to use only what? Half duplex, because in a shared channel there may be a chance of what? Overlapping of each other data. That's why you need to use a what? Half duplex communication there. So in multicasting also half duplex, only point to point. You say that you can use a what? Full duplex communication, but in all the cases you have to use what? Half duplex communication. Okay, friends. So we'll meet in the next class with topologies. So that is also another very important fundamentals, especially in interviews. So I'm focusing initially all the basics. So by tomorrow, the basics are going to be completed. That is a basic computer network. Then after that, we start entering into second part of your network. That is what? Data link layer, network layer, transport layer, and application layer, and the security. Some principles of security algorithms. After that, we are seeing IP addressing. But many of the students have requested me to start IP addressing. That's why after topology got completed, immediately as per the your audience request, I am starting IP addressing from day after tomorrow. And tomorrow, our schedule is as usually at 2 p.m. I'm going to start topologies. Some of the technical terms you all might be known. If you are a fourth year student, you all might be known that, but some of the hidden points you do not know. So that hidden points I'm going to cover. Please attend entire lecture, watch complete lecture. Somewhere you are going to have a one hidden point that may be your campus question or interview question or net question. And we are going to run tomorrow 6 p.m. quiz on whatever the fundamentals I taught. Whatever the fundamentals are there, tomorrow we have a quiz 6 p.m. This is I'm doing on Unacademy student learning app. All of you please download. And tomorrow this is as usually YouTube class only. So you are going to get broadcasted. I'm doing broadcasting only YouTube. Casting is nothing but broadcasting. Please understand. YouTube casting is nothing but podcast, also called as a broadcasting. So on YouTube, we are going to have this on 2 p.m. exactly. And the day after tomorrow, and this quiz, don't miss this quiz, all of you. Humble request, all of you, please attend this quiz. So I'm going to take around 40 to 50 questions of 1 mark, which are simply answerable. But logic is there and some application oriented. So we need to know the complete knowledge of all my previous classes. That's why watch all my previous computer network classes before attending this quiz, which we are meeting at exactly 6 p.m. Then day after tomorrow onwards, we are going to start IP addressing. So 10th September, we are going to have IP addressing, which I am going to take around 6 to 7 sessions. Consist of, I will discuss about subnetting. Don't miss IP addressing, as I am a Cisco certified. Then you are having a supernetting here. And also I'm going to discuss about the CIDR notation. And also I'm going to discuss in CIDR how can you do subnet and how can you do supernet. And today I discussed about a few of the broadcast addresses. What are they? NBA I discussed, as well as SBA I discussed, as well as DBA is there, as well as LBA is there. So we are going to see all the four kinds of broadcast address like NBA, network broadcast, subnet broadcast, directed broadcast, limited broadcast addresses. We are going to see from 10th September. And another important, very important news. So maybe next Monday onwards, I'm going to start DBMS on Plus. DBMS on Plus. Those who are authorized students of Unacademy can watch this from scratch. Full comprehensive database management system, which starts timings from 6 p.m. to 7 p.m. to 9 p.m. Please, those who have not taken admission in Academy so far, please immediately join and take the subscription. And the sessions are coming from mostly 14th September, that is from Monday. Don't miss from the starting class of DBMS. So, which is a continuously run or entire September month. It is only for plus students, not the pre of class. This is our next schedule. Okay, friends, we will meet on the tomorrow session. Use my referral code to get the admission into an academy, as we are starting the syllabuses, as we are starting the complete syllabuses according to the syllabi without missing a single concept on plus. So please all of you take the admission.